Hi guys, so this quiz is a group quiz that you guys are going to take together, and the point of this exam is to test your abilities on mass and change for particle diagrams and the law of conservation of mass, as well as identifying a physical chemical change in the system and its surroundings. So we recently analyzed chemical and physical changes behavior in systems and their surroundings, as you see below. And so for the examples below, you are going to indicate where whether it's a chemical change, physical change, and also the particle diagrams for each process that is taking place with a key. The change in the mass for the system that you choose, and the change of the mass for the surroundings that you have indicated. Now, to start, background information. Petrochemicals are chemical products that are derived from petroleum, although many of the same chemical compounds are also obtained from other fossil fuels such as coal, natural gas, or renewable sources such as corn, sugarcane, and other types of biomass. These fuels are made from long chains of hydrocarbons, which are compounds of hydrogen and carbon elements, with sometimes some oxygen and sulfur and nitrogen atoms, as shown below. So it's a long chain of carbon, hydrogen, and they take these different arrangements, and as shown in orange below, and they have different sizes depending on the chain length or the number of carbon atoms. And therefore they're given different names, and they're used as fuels as well. That's the form where, like, methane, ethane, propane, butane, these are alkanes, and they're used as fuels. So number one is the extraction process. So they drill for these petrochemicals or these fuels. Before they become petrochemicals, we have to drill for the fuel onshore and offshore. So I want you to tell me, in this drilling process, is this a chemical or physical change? And give me a reason why. Indicate the system and the surroundings that you would choose. For example, you're focusing on the petrochemicals now, or on the fuel. Where is your system, and where are the surroundings? And tell me the changes in the mass of the system that you choose, and also the change of the mass in the surroundings that you have indicated. I also need to see particle diagrams for the system and the surroundings, and indicate a key. So which particles are you interested in now, based on what I just explained above about the hydrocarbon chains over here. Now, the second step is crude oil refining. So after they're being extracted, they enter the oil refinery. And in this process, the fossil fuel enters a fractionating column where compounds separate according to their density. The most dense ones would settle to the bottom, and the lightest ones would be collected at the top tray, as we see over here. The number after the carbon symbol indicates the number of carbon atoms in the hydrocarbon. So C1 means one carbon atom, and so forth. So if we say C1 is CH4. If we say C4, then this means that we have 4 carbons. The more carbon atoms we have, the more dense it becomes, because it has more mass and volume, and therefore the density is going to increase. But the mass here, we're focused more on the mass. So tell me, is this a chemical or physical change, the separation over here of the crude oil when it enters and gets separated in this fractionating column? The fractionating column basically is just a column where we heat them to between 350 to 450 degrees Celsius, and according to their different densities, they end up being separated. They go to different trays, as we see over here. And once they enter the trays, we can withdraw them and use them as fuel. So refinery gas is the first one, and then gasoline, or we call it liquefied LPG, liquefied gas, petroleum gas for C1 to C4, the one that we see in lighters. And then we get petroleum and gasoline, and then naphthalene and kerosene, diesel oil, lubricating oil, and fuel oil. So these are ready to be used. However, I'm asking about this process when they get separated. Is this a chemical or physical change? Can give a reason why. Indicate your system and surroundings. the change in the mass for the system that you choose. This might be a little bit tricky, by the way, to indicate the, you know, the system surroundings and the change in mass, but I want to see how you guys would think about that. The change of the mass of surroundings, and also particle diagram that you are considering, okay? So what particles are you looking at in this case, and where are they now, okay? But I would say simplify things. So if you want to consider all of these trays as one location, you can do that as one location, and then that location could be another one as well. I mean, at the beginning, before they enter, and after they leave the fractionating column. So you don't have to like show particle diagrams of all of the from C1 all the way to C7. You can just talk about hydrocarbons in general and indicate where the particles ended up before and after the separation. The next thing is the energy production from the fuel. It occurs by combustion in an engine, producing in a process called combustion, producing carbon dioxide and water vapor, which is used as electricity and for fuel. So electricity in your house comes from burning of these fossil fuels at power plants, and you see that also this fuel could be directly used for fueling cars or engines for airplanes or rockets, or could be used for candles and all of that. So, but that has consequences on the planet, and I will also show you now the I mean, I could indicate an equation for you here, but I want you to look it up if you would like. And then, so tell me, is this a chemical or physical change? Tell me why, and indicate the system and the surroundings that you're choosing. The change in the mass for the system, the change in the mass for the surroundings, and show particle diagrams with a key. It's important to consider what process is taking place here and all of the information that is given to you. You're going to work on this in teams. And going now to the next page, we have particle diagrams. I need you to draw particle diagrams to trace the location of carbon atoms in the carbon cycle as they began as fossil fuels and in the soil. So we have carbon not only in fossil fuels, also the soil contains carbon compounds, organic compounds, right? So I want you to trace them all the way when they were on Earth, and then until they became carbon dioxide. So I want you to show me a cycle. Where am I finding these carbon atoms? I want you to think about what's your system and surroundings in this one, and what happened to the total mass of carbon in your system, basically Earth. If we choose Earth as our system, what's happening there? What happened to the total mass of carbon in the surroundings now after that change? What happened to the total mass of carbon in the system and surroundings even after the change? What impact does the change in the amount of carbon in Earth have on the soil? What impact does the change in the amount of carbon in the surroundings have on the planet? What is your recommendation, or what are your recommendations to restore any changes and reverse the changes in the mass of carbon? So carbon was in the soil or in fossil fuels, locked in, and now it left. And the whole point is to try to lock it back inside. We call it carbon sequestration. So carbon, I'm gonna draw here now. So carbon used to be here in Earth. That's our system. And then it ended up going to other places. And we want to trace, which is basically the surroundings. So you want to tell me what happened there and how it happened, trace it and label it. And what are your recommendations to restore? And in that, I'm going to give you a keyword here. This is called sequestration. Sequestration. It's a big word. We call it carbon dioxide sequestration. And a lot of coral reefs do that. Trees do that. Ants, they help the soil do that by digging and allowing the CO2 to enter the soil and then react with other elements. So I just want you to tell me, according to the law of conservation of mass, what is happening to the carbon and where is it going now, okay? So it's important to also refer to the law of conservation of mass. So now in your groups, you're going to work on this and you're going to submit your answers so we can see what you guys have in mind.